Hi, this video is all about the chapter electromagnetism. Before getting into the actual concepts of the electromagnetism, that is with respect to Faraday's laws of electromagnetic induction, first law, second law, Lenz's law, let us understand what is actually this electromagnetism. So, as I said, um, a magnet, as we all know, attracts iron fillings. So, in nature, magnet is found in the form of iron ore, which is an oxide of iron or ferric oxide, and is also known as magnetite. The word magnetite. Such neutral magnets are too weak to have most practical applications. So the magnetic field probably with such natural magnets would be very weak, where we can use for the practical applications. Therefore, artificial magnets known as electromagnets are built, which have several practical applications. Materials such as iron, cobalt, nickel, and other alloys are magnetic materials. When bars of such materials are wound with a coil and current is passed through them, just like your solenoid, okay? A solenoid wound with a coil and you pass a voltage, the current flows there. So they become electromagnets. So, like that, when you use such materials like cobalt, nickel, and when you are wound with a coil, on those material and current is passed by applying the voltage, this material, cobalt, nickel, and the alloys will become electromagnet. That means you're magnetizing those materials. So the strength of such an electromagnets depends on the number of turns in the coil and the magnitude of the current is passing through it. So hence, by increasing the number of coils on those materials and also increasing the current passing through them, an electromagnet of any strength may be obtained. That is, the required strength can be obtained. So, so overall, electromagnetism is the study of interaction between the electric and magnetic fields and forces. So, we're going to study the interactions between the electric and magnetic fields and the forces also. So, according to the Faraday's laws of electromagnetic induction, okay, laws of magnetism, okay. Before getting into Faraday's laws of electromagnetic induction, let us define the laws of magnetism. We all know, we have studied in our lower classes, like law 1 states that like magnetic poles repel and unlike poles attract each other. So, like poles repel in the sense, we can say the north pole and north pole will never attract, okay, when you have unlike poles north and south, so this will have the attraction. So when you have two magnets, you might have experienced, okay, one side of the magnets, one end of the magnets might attract. If you reverse the ends, probably they repel. So that means we understand they are unlike poles when they repel, and when they attract, they are like poles. Sorry, like poles repel and unlike poles are attracting. So law 2 states that laws of magnetism, under that we have laws, second law, the force of attraction. So always the magnetic field will be from north to south, the direction. So this force of attraction or repulsion between the two magnetic poles is directly proportional to their strength and inversely proportional to the square of the distance between them. Okay, so this is the general laws of electromagnetism. So some important definitions, so we need to study about this, is the magnetic field. So any two poles we have, like here north pole and south pole, the region or space around this magnet in which the magnetic effects are felt is known as magnetic field. So the field is drawn here, which is showing from north to south pole, and this field is called magnetic field, or we can say magnetic lines. So as I said, the direction of the magnetic lines is from north to south indicated. If you observe these lines, which is very close to uh, the poles, okay, from north to south poles, so very close to poles, this have more the flux density than the outer flux. So this will have less strength comparatively with this flux magnetic lines here. So then what is magnetic flux? Okay, so when you talk about a magnetic flux here, the definition what we give for magnetic flux. Okay, the magnetic flux is defined as number of magnetic field that is passing through the given closed surface. So if you look at this picture, this is the number of magnetic field that is passing through this surface. So these are the fields I'm talking that is passing through this surface. This is the number of magnetic field passing through the given closed surface. We call that as a magnetic flux. So generally the magnetic flux symbol is represented as phi. Okay, so this is the general symbol what we use for magnetic flux. So flux is also given as B into A. That is B is the flux density and A is the area. Okay, and you can also write this as flux as cos theta. Okay, where theta will be the angle at which the field line passes through the given lines. Okay, so flux density, as I said, so if you take cos theta as 1, so flux density can be defined as B is equal to phi by A. Okay, this is another definition we have here for magnetic flux density. That is, the maximum flux density or magnetic flux density will be equal to total number of flux divided by the area. The flux what we were discussing, magnetic flux, the unit of flux is Weber. Okay, so if you take this becomes Weber, area will be all in meters square, so the flux density unit will be Webers per meter square. So next, let us discuss on so magnetic flux density can also be used as Webers, or or you can also used as flux density, Webers per meter square can also be given as Tesla. Okay, the unit what we used for the magnetic flux density. Now, what is magnetomotive force? So, as I said, we discuss about the attraction, okay, the between the magnets. We discuss about the force. So, what is this force? So, magnetomotive force. So, MMF. So, in short, we call this as MMF. That is magnetomotive force. It is defined as the magnetic force which creates magnetic flux in a magnetic material. The unit is given as ampere turns. So SI unit for this is ampere turns. So where MMF can also, ampere turns, it can also be defined as MMF is number of turns into I, where I is the current flowing through the coil and N is equal to number of turns in the coil. So put together it is taken as ampere turns, where N number of turns refers the turns and current will give you the unit as amperes. So that is all about the introduction of electromagnetism. in this video. In the next video, we'll discuss about Faraday's laws of electromagnetic induction. Thank you for watching.